Example 4 says, which of the following functions are not which of the following are functions and which are not functions? So functions and not functions have to pass something called the vertical line test. So what I can do is I can draw a vertical line, and if that vertical line passes through the graph more than once, then it is not a function. So in this case here, we can see clearly that at many points, that vertical line will cross the graph. So here we have 2 points. So at x equals these 2 points here, the same x, there's 2 different y values. That does not pass a function test. For this b, it is a parabola, and parabolas pass the function test because we can drag that line anywhere on that curve. It only crosses once. So it passes a function test. So we have here not function for A, and for B we have a function. We could do then the function test, the vertical line test for C, and we can see that at many places it crosses more than once. This does not pass the function test, so this is not a function. The linear equation, all linear equations, straight lines are functions. It only crosses once, so we can just state that is a function. So any linear equation or straight line equation will be a function. For example 5, it says, find the perpendicular slope of the following linear equations. Well, we need to first of all find the slope of that equation, and then we can determine the perpendicular slope. So first of all, in y equals mx plus b, there is my slope. So my original slope is equal to -3. If you want, you can write it as -3 over 1 because any slope has 2 parts to it. The perpendicular slope then is going to be the negative reciprocal. So we flip it upside down, and if it's negative, we make it positive. If it's positive, we make it negative. So in this case, we started with negative, we need to end with positive. For b, it's hard to tell what the slope is, so what we can do is we can first of all solve for the y, and that's going to give us y equals mx plus b. So notice I subtracted 2x from both sides, added 6 to both sides, and we end up with dividing -2 over 3x. So there's my slope, there's my y-intercept. I'm interested in my slope. Okay, so then once I have my slope, I can get the perpendicular slope, which is +3 over 2. Example 6, we're given 2 points, and we need to determine the equation of the line. So to determine the equation of the line, we need to first of all find the slope. So I'm going to just sketch what this might look like. Okay, I'm just going to give myself an idea what this graph looks like. So 2, 3, maybe I'm going to estimate it to be about here, 10, -1, maybe somewhere around here. So I know my line kind of looks like it passes through those points like that, so maybe something like that. Okay, so I'm going to calculate my slope first. And to find the slope, I need my rise and I need my run. So to get my rise and run, I'm going to take the difference between the y coordinates. So I'm going to go -1 minus 3. That's my rise. So in this case, it's gone down 4. And then my run is going to be, if I start with -1, I have to start with 10 minus 2. And that's going to give me a run of 8. So that ratio can be simplified to -1 over 2. So that would represent my slope. Now, I can do this many different ways to find the y-intercept. So I can do this. I can just go y equals -1/2, that's my slope, and then x plus some unknown b. And I can find that unknown b by plugging in one coordinate. So it doesn't matter if I put a in or b in, but any pair will help me solve for that unknown term. So if I replace y with 3 and x with 2, and what's left over then is my plus b. So that's the only thing left to solve for. So solving this, I get 3 equals -1 plus b. B's equal to +4. So my equation then looks like this. Y equals -1 over 2x plus 4. So that represents the equation of my line in y equals mx plus b form. Now, it's much easier if we just think of it as point and slope. So I have my slope, which is -1/2, and I have a point, and I have two different points I can use. In this case, the first one I use 2, 3, but in the second one, I'll just use the other point. I'll just go x minus 10. So that minus 10, the 10 in that position there represents the x coordinate, and then minus 1 represents the y coordinate. And that's coming from these coordinates here. That represents my x coordinate and y coordinate in the point slope form. Now you can leave this in this form if you like. If you want to see the y equals mx plus b form, what we can do is just multiply out the brackets. So we get -1/2 x. -1/2 times -10 is +5 minus 1. When I group those two terms together, I get -1/2 x, and then these group together to give me my y-intercept. So my y-intercept works out to be +4, which is what I got in my original. So those are two different ways we can do it. One is substituting to solve for b in the y equals mx plus b. The other is to just write it in the point slope form, and we can leave it like that, or we can expand the brackets and combine like terms to get the y equals mx plus b.